All right, good afternoon, everyone. Thanks again for joining us today. My name is Joni Burchett, and I'm the Channel Development Manager in North America for Novacura. In today's webinar, we're going to tackle IoT head-on, and we will be discussing how you can link IoT devices to your IFS applications with Novacura Flow. The webinar will be presented by Greg Warner. With over 20 years of experience in the technology field at various software companies, Greg is very familiar with the latest innovations and technology trends. As a former technical director at IFS, he has a deep understanding of IFS applications and now leads the technology vision and strategy for Novacura as the Chief Technology Officer. So let's take a look at the agenda for today. So the reason we're hosting this webinar is because we get asked a lot of questions about how businesses can leverage their existing business systems but still stay on the cutting edge of technology with IoT. Rather than go through a bunch of bullet points and boring PowerPoint slides, we felt that it would be best to show you some real-life examples of how businesses can leverage IFS applications and incorporate IoT devices into their environment. Therefore, we will provide you a business and IT scenario to set the stage, and we will go right into showing you how Novacura Flow can help in the following areas. We'll show you how you can easily integrate automated equipment with IFS asset management or any of your other business systems. We'll show you how you can generate actionable insight from your IoT data. We'll show you how you can set up push notifications to alert users to key business events. And we'll show you how you can digitalize your IFS applications to better support your mobile workforce, both on and off-site. Lastly, we'll leave some time at the end of the presentation to answer any questions that you might have. And with that, I'll hand it over to you, Greg.
Thank you, Joni. Welcome, everyone. As Joni mentioned, we're just going to walk through an IoT example today. This is just one of many possible ways of handling IoT solutions. This happens to be an approach where we've seen many similar examples out in the market. One of the things I think is a bit challenging about the whole IoT space right now is there's all kinds of buzzwords involved that you can see here. Artificial intelligence and business intelligence and IoT itself, big data and microservices. So what we're trying to do in this session is just take maybe one simple path with some of these things. We're actually going to touch on a number of these topics as we go through the demonstration, but we're hoping to keep it fairly simple and straightforward to just show, again, one possible scenario of how these things can fit together. And we can build an IoT solution that is pretty simple to set up initially. It's easy for us to deploy and easy to maintain. So that's the idea of this session. Again, not trying to be the end-all, be-all of all things IoT, just kind of a simple way to get it set up and working and start seeing some benefits. So to give you a little background on this particular scenario. So we're going to pretend to be a fictitious manufacturing company. We're running IFS applications as our ERP, of course, and we are doing extremely well. Our orders are increasing, but one of the challenges we have with our business growth is that we have a lot of equipment outages on our shop floor, and we are in reactive mode when it comes to maintaining that equipment. So things go down and we are just reacting and sending technicians out trying to repair them. It's shutting down our line. So our business is pushing us to be a bit more predictive about our maintenance. So they're trying to come up with ways where we can predict ahead of time before outages occur and get things resolved so that we're not shutting down the line. So pretty simple scenario. That's just to kind of give you an idea what we're looking at today. From an IT perspective, in our made-up scenario here, our situation is that we do have some sensors in place on our shop floor equipment. And those sensors are capable of sending telemetry messages to some sort of data collection service. We'll walk through in a fair amount of detail the technologies we're using in this use case scenario. But there could be many. There's lots of different ways to collect this sensor data. We're going to use the Azure IoT Hub for that today. But our current state as an IT department is that we do have this information and we have devices capable of sending it off so that we can collect that data somewhere. The other thing that we've done kind of moving us towards this direction of predictive maintenance is we've worked with our business users a little bit, and they've helped us define conditions that we think we care about. So in this scenario, we're looking at temperature readings, and we've worked with the business users to define some triggers that say, hey, when certain conditions occur with temperatures, when we have so many readings over a certain time span that exceed a certain temperature, for example, we know that that is something that predicts a maintenance condition, and we want to be alerted when that happens. The other piece we're working with here is we use IFS applications for our asset management. So whatever we're doing here with IoT, we want the measurement information captured in IFS apps. We're going to create fault reports in IFS applications. We're going to go through the process of assigning those fault reports to technicians and moving them through the whole work order process. So again, in this situation that we're walking through, the integration with IFS applications is critical, and that's a big piece that we're going to cover here. But then the question is, how can we quickly and cost effectively connect this monitoring technology that we have to IFS so that we can kind of get this predictive maintenance concept moving? So that's what we're going to walk through. So we'll talk a bit, and I will jump into demo right after this, but we'll talk a bit about the components of this example just so you have a better idea what we're looking at. And then I'll walk through the demo itself. We'll show some messages being sent to the Azure IoT Hub. We'll show some push notifications being sent to a technician user, and we'll show some integration into IFS applications. But first, we'll just kind of walk through the pieces that we're going to show here. So step one of this process is the equipment monitoring itself. And what we're going to use for our demo is a Raspberry Pi simulator. I'm going to assume most of you are probably familiar with what a Raspberry Pi is, but since I can't show you a physical one, there's an online simulator that we're going to use. And the simulator is virtually wired up with a temperature sensor, and it is capable of sending temperature readings every 2 seconds. So when we start out this demo, that's what you're going to see. That Raspberry Pi simulator is going to serve as a sensor connected to a piece of equipment on our shop floor, and it's going to be picking up these temperature readings and sending them pretty frequently. The next thing we need to do is be able to collect that data somewhere. And in a real world scenario, we would have dozens, potentially hundreds of these different sensors sending messages frequently, every 2 seconds, potentially even more, depending on our requirements. So we need some piece of software that can register those devices. So basically be aware of the different devices and sensors that we have in our environment, and can quickly collect large volumes of data. I mean, as you can imagine, if we've got hundreds of equipment objects out in the field, all of them sending messages every 2 seconds, we are going to generate a huge amount of messages. And we need something that's designed to deal with that kind of volume. So in our case here, in this example, we're going to use the Azure IoT Hub for that. There's many other options. There's lots of third-party vendors that provide products like that. We're just happening to use Azure for our example here. The next step then is we're going to collect hundreds and thousands of these data points from our equipment sensors. We need to be able to analyze that data and turn it into something useful. So as it comes in, it's very raw. It's just temperature readings in our case. The vast majority of those are going to be meaningless. So we need something that's constantly monitoring that data coming in, looking for whatever we have defined as alert conditions, and then allowing us to act only on those important data elements. So again, there are many products in the market that can do this piece. What we're going to rely on for this demo is called Azure Stream Analytics. And it is essentially just reading that stream of messages that comes into the IoT Hub. And then we provide some logic in Stream Analytics, which we'll get into details of how that works, that determines what we're looking for. So it defines exactly what we would consider an alert condition to be, and it picks out the alerts the relatively small number of alerts that we're going to get in this massive stream of data coming in. And then the last step we're going to get to is, okay, what do we do now when we get one of those alerts? So we've collected a ton of data, we've done some analysis, we know now there's potentially a problem with a piece of equipment on our shop floor. Now we need to actually do something about it. As I mentioned earlier in this scenario, we are using IFS applications for asset management, so whatever we do, we want it to be integrated there, and that's where our product, Novacura Flow, is going to come in. So we are going to react to the alert that Azure Stream Analytics identifies. The first thing we're going to do is notify a user that has occurred, and we're going to do that by sending a push notification to that user's mobile device. Then we're going to collect some input from that user. So we're going to let a person do some analysis on this alert. They're going to take a look at the piece of equipment that had the problem. They're going to look at the historical work orders on that piece of equipment to see if there's some sort of trend potentially. They're going to look at previous measurements that we've taken, previous alerts that have occurred on that piece of equipment. And if that particular technician user feels like there's an issue here, then we're going to allow them to create a fault report directly from their mobile device and push that straight into IFS applications. So that's the basic flow we're going to walk through. And I'll go ahead and show it to you. So here is our fictitious device for this scenario. A nice pretty picture of a Raspberry Pi. What I'm going to do here is just hit run. And that is going to trigger this mock device to start sending some temperature readings to the Azure IoT Hub. And I'm probably going to let this run 30 seconds to a minute. We've got some rules behind the scenes where as temperatures start to exceed 30 degrees, that's going to trigger one of these alert conditions, and we should see some push notifications showing up on our device here shortly. And actually, I'm going to bring up our mobile device as well. So you should be seeing the iPad now. This is the mobile device that we're using for our demo. If you take a look at the notifications, so all of these alert temperatures, these notifications came in. My alert conditions are quite loose because I want to make sure that we're getting some notifications here that we can walk through. So just from running that Raspberry Pi simulator for a minute or so, we triggered a whole bunch of alert notifications that came in to the mobile device. We'll go ahead and select one of those. And when I pick one of those, it is going to launch the Novacura Flow iOS application. And it's going to go ahead and invoke a specific, what we call a flow. So a specific mobile application that is designed to respond to these temperature alerts. So it is giving me this notification that we've had a high temperature on a specific pump. It's giving me the temperature reading there of 31.67 degrees Celsius. It's told me exactly what pump this is. This happens to have a location link. So if I click on this pump, it's going to show me exactly where it's located. Not coincidentally, it happens to be right here at our office. It has also picked up an attached document that comes out of IFS applications. So in our example here, we attach the maintenance manuals to our equipment objects in IFS apps. And this mobile application we're using is designed, as soon as I get one of these alerts reported, it is designed to go ahead and bring up whatever documents are attached. So if I wanted to take a look at the maintenance manual here, I just tap that and I get the PDF document with the maintenance manual. A couple other things that are going on here is at the top of this application, I've got two things that we call pins. So these little tabs at the top, if I click this pin with the technician icon, that is, again, pulling information out of IFS applications. So for this particular equipment object, it's going out and grabbing the historical work orders from the database and listing the summary of those here. So as the technician, I've now been alerted that we have a potential problem on this piece of equipment. I can take a look at the history and see, well, what work have we done recently? Does this look like something that's a trend that looks like a high risk of failure? The other thing I can look at to help me gather that information is prior measurements that we've recorded in IFS applications. So again, when these alerts are generated through the Azure Stream Analytics, the first thing we're doing is taking those temperature readings, the 31.67 here, and recording those as measurements on the equipment object in IFS. That gives us this history of data. It also gives us the capability of automatically generating some condition-based maintenance if we wanted to do that. But right now we're going to let a user intervene first. So once I've reviewed that information, I have the option of creating a fault report or not. So I can make a decision here that says, no, I don't think this warrants a fault report in this case. I would say no and move on. I'm going to go ahead and say yes. This does in fact concern me. I'm going to create a fault report. And we'll tell whoever the technician is to investigate. And we had a high temperature alert. The discovery code is an alarm. And if I happen to be looking at this device at the moment, since I'm using an iPad here, I could take a photo if I see something, a crack or some sort of condition on the device where a photo would be useful. I would just click upload here and it would let me either pick an existing file off this iPad or just take a photo. And then we will attach that to the fault report in IFS applications. And we've done that in a couple different ways with different customers. Sometimes we attach it as a document management attachment. Sometimes we attach it as a media library item. I'll skip the picture for now and just say report fault. And at that point, we have connected into IFS applications and created that fault report. And you may have seen a quick number change there. So this equipment alerts box right here, that is something that we call an inbox. So as these temperature alerts are coming in through the IoT hub, they drop into this inbox. So any user, any Novacura Flow user who has access to this application will get the push notification, which we saw, and then they also will have access to this inbox, which has all of the push notifications in it. And when I completed that particular one, it dropped out of the list. So our inbox dropped from 6 to 5. There's a number of different ways to do this in Flow. We could send these alerts to one specific person, but this is probably the more common way, where we have a role defined who receives these types of notifications. Every individual user who's a member or who has that role can see the inbox, and they all get the text notifications. But the inbox prevents them from duplicating work. So once one person in that group takes care of one of these items, it disappears from the list on everybody else's view as well. And then in my mobile application here, I'm not going to walk through these other examples, but I've got some other capabilities that I could do. I could go through I could create another fault report just based on something I observed from an inspection rather than triggering from one of these alerts. I have another inbox here that is collecting work orders that have been assigned specifically to me. So if I click there, you can see I've got 4 of those items in my queue. Again, this process that we're going through is automatically collecting measurements on the equipment. If I wanted to record those manually, I have a little app here. I could do that as well. And all of these apps that I see when I log into the Novacura Flow application are based on my role. So a different user signs in with a different role. They may see a different collection of mobile applications here. So that's basically the initial part of the demo. I'm going to jump back into the PowerPoint slides here for a minute. And I want to talk a bit about the technical components that we're using in a little bit more detail to get all these pieces tied together. So the first part of this, the part that represented our piece of equipment on the shop floor, was this Raspberry Pi simulator. We do actually, in our office here, have a physical Raspberry Pi device that does the same thing. It has a temperature sensor connected to it. You can grab a hold of that with your hand, and that will increase the temperature enough to start triggering some of these alerts. We just can't show that very well on a webinar, so we're using the simulator for now. But it basically looks just like this. It's a Raspberry Pi, a small computer device, basically, with a temperature sensor wired to it. Microsoft makes what they call the Azure IoT Device SDK. So that is software that resides on the device itself that allows it to send those alert messages out to the IoT hub. So that's the technology that we're taking advantage of on the Raspberry Pi. Again, there are many third-party products that can do similar things. The Azure Device SDK can run on a bunch of different platforms. This is just what happens to be what we're using in this particular scenario. So then the next piece that we talked about, the collection of all this sensor data coming through, as well as identifying the devices and kind of handling security around what devices are allowed to send us messages and which ones aren't. That is all happening through the Azure IoT Hub. So it is a pretty lightweight cloud service that you just configure. There's no code involved here. You set it up, you add devices into the hub. It gives you a connection string for each device, and you basically plug that connection string into the device SDK, so it knows where it's sending the messages. And then this gives you the capability of collecting large volumes of messages from a huge number of equipment objects if you really want to do that. The next piece then is the analysis of all that sensor data coming in. That's being done, as I mentioned before, through Azure Stream Analytics. Excuse me. And we'll get into a little bit more detail about how you create these Stream Analytics jobs. I've got some screenshots and examples of how the one that we're using works specifically. But the key elements of it are, you have an input. Our input in this case is the Azure IoT Hub. So that is pure configuration. We just give it some connection information about our IoT Hub, and it will connect to that on its own. And then we specify an output. And in this case, the output is going to a Novacura Flow event listener. So that's a component of our software that is basically sitting there waiting for events like this to occur so that we can react to them. And in the middle there, you have something called a query, which defines the conditions that you're looking for on that stream of data. And I've got some more detail about how that works in this example. And then comes our product part of this, the Novacura Flow portion. So it has the listener component that is sitting there waiting for these IoT events to occur and to do something about them. When we do have an event that occurs, that event initially triggers what we call a machine flow. And that's basically an app or a workflow, and I'll show you what it looks like. But it's something that responds to some kind of machine interface, not to a user. So that machine flow picks up the alert from the Stream Analytics job. It sends out a push notification to the end user, which we looked at a little bit on the iPad. And then it also goes ahead and records the data from that alert as a measurement in IFS. So that's happening automatically without any user interaction. The push notification then acts as a link. So as we saw in the iPad, that goes to the end user. The end user just touches that push notification and it drives them into the mobile app that handles the ERP integration. So it's going out and querying data from IFS, pulling back things like the work order history for that equipment object, and then it's allowing the user to go ahead and create a fault report as well. So the Stream Analytics part. If I were to go into the Azure portal, this is what the analytics job looks like. It is purely configured in the portal. The only code that was involved in setting up that job, excuse me, is this query right here. And again, our input here is the Azure IoT Hub. The message coming to the IoT Hub has these data elements in it. It has an equipment ID, a test point ID, a parameter code, a measurement. And then what we're doing is selecting these items in a stream as they come into the IoT Hub. We're giving them a timestamp of basically when they appeared in the IoT Hub. And we are looking for any measurement values greater than 30. And we want to know if those happen within a sliding 30-second window. So again, that's a really loose use case that's going to get triggered quickly. We're doing that on purpose in our case because we want to make sure these alerts go out fast so we can show them. So in the real world, you'd have some tighter rules than this, but that's basically what we're looking for. As that stream of temperature measurements is coming in, we are taking this sliding 30-second windows, and we're looking for any time you get more than one measurement of 30 degrees Celsius or higher within that 30-second window. And then this is all the code that we've written. So we have an input that's just configured to point to the IoT Hub, and we have an output that's configured to send to the Flow event listener, and our coding here is basically done. Then from a development standpoint, the only other development work that we actually did to make this kind of scenario work was creating this flow. And this is a screenshot from our Novacura Flow Studio, which is the tool that we use to build these applications. The top swim lane of this is the portion of it that I was describing as the machine flow. And I'm just going to actually jump into our studio and show this so we can dig into it. So the top portion is the machine flow. This is what is reacting to those alerts coming in. This machine flow, if I double click on its starting point here, these are the data elements that it is expecting to receive from the Azure Stream Analytics job. So it wants an equipment ID, a test point ID, a parameter code, and a measurement value. Pretty straightforward. Every time we see one of these little gear icons in the flow, some of you, I think, have seen this tool before. You'll recognize it, but those we call machine steps, and those can connect into some sort of back-end system. In this case, the back-end system that they're connecting to is IFS applications. So if we double-click there, it's going to give us a SQL-like interface. So we're just taking the test point and equipment information that we received as input, and we're going and querying from IFS apps some additional information about that particular equipment object. And then we've got another IFS API call here that's going to record that measurement in the ERP system. And then we have this little step in the flow that's called a split, which means we're going to kind of branch off in two directions in parallel. So from the machine flow standpoint, we're done and we're just going to end. But we're also going to trigger a branch here that goes off to a user-oriented portion of this flow. And this little wrench here at the line between the two swim lanes is what's triggering our push notification. So we're basically saying, hey, when we reach this point in the process, we want to send a push notification out, and it's going to say, an alert of this particular parameter, we got this value and it was recorded on this piece of equipment, and this is the name of that equipment. So that is the push notification that we saw show up on the iPad. And then once that notification's sent, we start triggering down this part of the flow. So this is now the user part that we saw when I was on the iPad. Each one of these little person icons represents a screen that the user will see as they step through this. The first two were the pins. So this was the pinned step that shows the work order history. And that's just, again, the result of a query going into IFS applications. Then we have a query that retrieves prior measurements for that particular equipment object. Those are displayed on a pinned step. And then I get to the step that showed that we had a high temperature recorded. It has a link to show me the map location of that equipment object. It has attached documents that allowed me to access the manual for that equipment. And then it asks me this question of if I wanted to create a fault report or not. And then my answer to that question drives us down two different paths. So if I say no, we just close this thing out, it disappears from the inbox and we're done. If I say yes, then we go and ask for a few more fault details, and then we start making some additional IFS API calls to create the fault report and to attach a photo if I took one to that work order. Again, the connectors in this flow are all specific to IFS applications. Our product, Novacura Flow, actually offers a lot of different connectors. So we could do some generic things that are not specific to IFS, like making REST service calls to external systems. We could make SOAP API calls to other systems. We can query other types of databases. We can connect to SharePoint. There's quite a big library of different connections that we could do when you're building an app like this. But in this case, we're talking to IFS. And as a developer, you can see I've got some basic check-in, check-out of this application that I've built. So you can see the history of versions over here. If I wanted to do some work on this, I would just go ahead and check it out. And then we get a new version that'll show up in the box here. Once I've made my changes, I can check it back in. And then all I have to do is hit publish. And that publish step will make this new version available on the iPad. So if I had made some changes in here and I came in and clicked publish, as soon as I were switch over to that iPad, those updates would be available to the users. So if I had some additional fields or some additional logic that I wanted to apply in this flow, it's pretty quick and easy for me to make those changes and push them out to the users. So that's the development parts of this. And we walked through that Flow Studio demo. So that's basically has covered it. Now we've gone through the demo and some of the technical parts, so we can open it up for questions that you guys have on any parts of this. It could be the functional parts of the demo or the technical parts of how we built these things. We're pretty open.
Thanks, Greg. As a reminder, if you have any questions, you can raise your hand in the webinar console and we'll be able to unmute you to ask your question, or you could submit your question via the Q&A tool and we'll address them as they come in. So I do have a question for you, Greg. Are you reselling the Azure IoT pieces?
No, we are not a reseller of Azure services. I mean, the only piece of that you could say we sell is the component of ours that's able to respond to the events. So in this demo, I'm showing our Azure version of Novacura Flow. So it's our cloud version, which happens to be hosted on Azure. And it ties in pretty easily with the IoT Hub and Stream Analytics, but we do not resell those components of it. It's just what we used as the example here. And in fact, when we've implemented similar solutions in the field, in most cases, those are actually done with specific third-party products that provide similar functionality to what Azure does. Azure just gives us a good kind of generic way to show it in demos like this.
All right, it looks like we have another question from Lisa, and it's, are you limited to the EAM functions, or can you leverage all of available IFS APIs?
So we have access to all of the IFS APIs. For those IT people in the crowd, we go through the IFS .NET Access Provider, which opens up access to any of the functionality within IFS. So again, just for this example, we're going through EAM related items, but we build mobile applications that talk to all different parts of IFS. And in fact, one of the common things we do is you can access these same applications, what we looked at in the iPad, you can access through a web browser. And because IFS Enterprise Explorer has a web browser baked into it, you can actually kind of incorporate some applications like this into Enterprise Explorer itself. So as an example, internally, we are also a customer of IFS applications and our own product Flow. Internally, we've created a wizard application to create projects, for example. And you access that from within IFS Enterprise Explorer. So it becomes a right mouse button option that you can launch without actually ever leaving IFS EE.
Do we have any other questions? It looks like we had one more, Greg, and it's asking about, it's from Bob, and it's asking about how long or how would you go about connecting to IoT systems? Like, what is the deployment look like?
In terms of like what has to be installed?
How long it takes typically?
I mean, it's going to depend on what system we're talking to. So in this Azure example, almost everything is just configuration. So in this example, to set up the IoT pieces, I just had to go into the Azure portal, create an IoT hub, and create a stream analytics job. That's all just configuration stuff, and it happens pretty quickly. I was using our Flow cloud version, which gets installed also very quickly. That's an automated installation. If we were to do an on-prem installation of Flow, we have what we call the server manager that handles that. It's typically done very quickly too, within less than half an hour normally. If we're talking about third-party IoT software, yeah, that I can't answer. That's going to vary depending on what software is being used. Probably the most challenging part is handling the communication between the devices and the IoT software. That typically is the hardest part to get configured and figure out how to make work. Going from whatever it is that's collecting the sensor data from the equipment objects to through the IoT software and into Novacura Flow, that part's pretty simple. It's all pretty standard web service stuff typically that's not hard to set up.
Okay, great. And we have a follow-up question from Marcus regarding that. It's just asking about what does a basic system like this cost?
Yeah, I mean, that's a tough one to answer because we have user-based licensing, so it depends how many users you have on the system. And then in this whole scenario would also include some charges from Azure, and that's all pay as you go. So it's going to be transaction based in Azure, and then to use our Flow cloud version is going to be a per user per month type charge. And it's going to vary depending on how complex of an application you have and how many users there are. But we could easily follow up and talk more details if you want to do that.
Great. And the last question that we had, it looks like that's sitting here is, will the presentation be available to replay for other team members? And the answer to that is yes. We did record the presentation today, and we will be sending you a link to the recording after the webinar. And with that, I think we've answered or addressed almost all the questions. If there are no further questions, we're going to go ahead and close out the presentation. Thanks again for joining us today. We hope that you found the webinar valuable. I hope that we were able to address everything that you had for questions, but if you have anything left outstanding, please don't hesitate to reach out to us at any time. You can reach out to Greg Warner directly at greg.warner@novacura.com, and we'll be happy to address any questions that you might have or to talk to you more specifically about your situation. Thanks again for attending, and we hope to talk to you soon.